Iranian ballistic missiles strikes focus on key Israeli military sites such as Nevatim Air Base near Beersheba and Tel Nof Air Base, both of which house the billion-dollar Israeli F-35 fighter jets and other high-value assets. Additional targets included the Hatzerim Air Base in the Negev Desert and the Mossad headquarters in Tel Aviv. This is the Fatah hypersonic missile and the Shahab-3, and we'll look into the details why the Arrow missile failed to intercept the Iranian glide vehicles all in the video ahead. The U.S. traced the launch location to a valley south of the Iranian city of Shiraz. Iran has launched its largest ever attack on Israel, firing 180 ballistic missiles. These missiles traveled more than 1,000 miles from this valley to reach Israel's most populated city and military sites. Iran used variants of the Shahab-3 ballistic missile in its latest attack on Israel. The Shahab-3 is the foundation for all of Iran's medium-range ballistic missiles and uses liquid propellant. It can carry a warhead weighing between 760 and 1,200 kilograms, which translates to 1,675 and 2,645 pounds. How it works. Step 1. The missile is positioned at a 90-degree angle and then fired. Step 2. The ballistic missile's trajectory takes it outside or near the edge of Earth's atmosphere. Step 3. The warhead payload separates from the rocket that carried it aloft and re-enters the atmosphere, descending towards its target. Step 4. The missile can carry a single or multiple warheads, depending on the variant. The warhead separates from the single-stage rocket after it has traveled about more than half the distance to its target. The most prolific Scud variants had a circular error probable of 300 to 450 meters. This means that 50% of the missiles fired at a target would land within a circle of that diameter. This is the Fatah 2, the successor to the Fatah 1. It was used for the first time and is one of Iran's advanced missile systems. This missile is equipped with a hypersonic glide vehicle. Inside it is the warhead, which detaches and allows the missile to maneuver and glide at speeds between Mach 5 and 10. The missile has a range of around 1,500 kilometers, only slightly more than its predecessor, the Fatah 1. What sets it apart from other ballistic missiles is its ability to accelerate outside the Earth's atmosphere, while its aerodynamic control surfaces enable steering to evade the famous Arrow missile's defense system made by Israel. But first, let's look at what is a hypersonic missile. Hypersonic missiles are a challenging technology to master because they are so fast that if the US launched a Scramjet missile, it could reach China in just 18 minutes, traveling at speeds of Mach 5 and above. These Scramjet engines collect oxygen from the atmosphere as they travel, mixing it with hydrogen fuel to create the combustion needed for hypersonic flight. Meanwhile, glide hypersonic vehicles like the Chinese Dongfeng 17 became the first to integrate into production with conventional and nuclear warheads. They are also designed to target US aircraft carriers, as they can change their trajectory mid-flight. This US Arrow AGM hypersonic weapon is a missile within a missile which pops out its cover and uses only the glide vehicle kinetic energy as a weapon. And not to forget the Russian hypersonic missile like the Kinzhal. To qualify as a hypersonic missile, it must possess 3 key attributes: speed, maneuverability, and accuracy. Let's look at speed. As we all know, Mach 1 represents the speed of sound, which serves as our benchmark. To better understand this, let's make a few comparisons. Commercial airliners, for example, fly subsonically, just below Mach 1. In contrast, modern fighter jets can travel supersonically, reaching speeds of Mach 2 or 3. When we refer to hypersonic speeds, we're talking about anything Mach 5 and above. Space shuttles are an example of vehicles that travel hypersonically, often reaching speeds between Mach 20 and 24. But these can travel only for short distances at this speed. To sum it up, a hypersonic missile should cross Mach 25, which is around 19,000 miles per hour. But wait, that's not it. Hypersonic missiles should also have the capability of covering vast distances, such as from New York to Russia or from China to Texas and vice versa. Before we looked into how Fatah missiles managed to penetrate Israeli air defense, we have to understand how Arrow 3 missile works. The Arrow missile defense system consists of 3 basic parts: the missile launcher unit, the Green Pine radar antenna, and the Arrow missile. The missile launcher unit is composed of 6 Erector launcher tubes, housing ready-to-fire missiles. Positioned at the rear of a two-axle trailer, each launcher, when fully loaded with 6 launch tubes carrying ready-to-fire missiles, weighs 35 tons. The Green Pine radar serves as the warning and fire control radar for the Arrow 3 anti-ballistic air defense missile system. It plays a crucial role in target detection and guidance. The Arrow operates as a 2-stage missile. Let's look inside this engineering technology. This is the solid propellant booster and sustainer rocket motors. At the rocket's peak sits the ignition chamber, triggering the combustion of the solid propellant when activated. This propellant isn't just any substance. It's a meticulously crafted blend of fuel and oxidizer poured into a casing and then cured. Encasing this blend is a protective shell called the motor case. At the core of the rocket lies the propellant burning zone. Here, the solid fuel and oxidizer react, producing incredibly high-temperature combustion gases, which helps to launch the rocket at incredible speed above the Earth's surface. Moving further to the front, the most important part of the missile is the kill vehicle, which can be divided into 3 basic parts. The second stage is the propulsion system with a thrust vectoring nozzle. Just above it is the warhead, a directed high-explosive fragmentation weighing 150 kilograms, which translates to 330 pounds. The third stage is the seeker, capable of pivoting itself to track its target. But what's the big deal about this long-range anti-ballistic missile system? Let's start with the propulsion system. The famous THAAD, Terminal High Altitude Area Defense, uses a divert attitude control thrusters. In comparison to the Arrow 3 kill vehicle, which utilizes a thrust vectoring nozzle with a solid fuel rocket, it has a shorter and more limited burn time. It has a few advantages, one of them being the ability to compensate for a lack of radar accuracy. When the radar sends the interceptor to an inaccurate target location, the Arrow 3 kill vehicle can adjust its trajectory. Since intercontinental ballistic missiles travel at very high speeds, the kill vehicle must change its trajectory based on newer, more accurate radar data from its seeker. A failure to fully divert the course to the new target would result in a failure to intercept. Now let's take a look how the Israeli defense system works. The Israeli defense system consists of 3 tiers. First up is the long-range Arrow missile defense system, which was designed specifically with Iranian missiles in mind. Each of these system rockets costs a few $1,000,000, and they can intercept missiles outside the Earth's atmosphere, resulting in enhanced protection. The second layer of defense is the so-called David Sling system, designed for taking out missiles and drones. Finally, the Iron Dome stops most short-range rocket attacks in Israel. Let's take a look at why the Iron Dome failed to intercept the Iranian ballistic missiles. Apart from discussing the multi-layered missile defense system, the Iron Dome itself has a range of around 40 miles, while the David Sling can intercept ballistic missiles up to a range of 180 miles. The top-tier Arrow anti-ballistic missile systems can target threats up to 1,500 miles away. According to reports, 180 ballistic missiles, which are possibly hypersonic as claimed by the Iranian Revolutionary Guard, were launched. Although the Arrow missile defense system successfully intercepted many missiles before they reached Israel, many still got through. The main problem behind the failure to intercept was after the detachment of the glide vehicle from the launcher. The glide vehicle can change its trajectory multiple times, which confused the Arrow missiles. This maneuver also bypassed the David Sling and finally the Iron Dome system, which is not designed to counter hypersonic missiles like the Fateh II model. As a result, the interceptor missed for targets and the glide vehicle landed on military bases where the $100 million F-35 jets were stationed. Let's examine the cost implications of a single day of missile attacks. Iran expended over $200 million by launching ballistic missiles along with drones, whereas the IDF spent $1 billion to defend itself. This includes the Arrow missile, which costs around $2.5 million. The David Sling costs around $1 million to produce, while the Iron Dome costs around $20,000 to $100,000 for a single missile, depending on inflation. By contrast, Iranian ballistic missiles cost around $200,000 each, and its drones only $20,000 to $50,000 each.